Got it. Let me jump into share mode. Share the screen. Okay. Present. Okay, just quick check. Everybody can see the slides? Good, perfect. So again, Tim, thanks for the introduction. Thanks for the invitation. As we were discussing at the beginning of this, I'm very happy to be kind of a early person to be aware of CMU Africa because of my old friend, Bruce Krogh. And Bruce and I met quite a few years ago when we first started graduate school at the University of Illinois. And it's been a pleasure to be a friend of his for all these years and to develop a connection with CMU Africa. So my agenda today is really kind of four basic parts. I'm glad, Tim, you said at the end, I'm glad to answer questions all along the way. I didn't mean to pack the entire hour anyway. So I want to talk about our Moonshot mission, this mission to connect all million machines in all 500 children's hospitals in the world, what motivated that, and then talk a little about this new technology that we've developed, referred to as an edge cloud, as opposed to a center cloud, which you're all aware of as AWS or Azure, et cetera. I want to show you some applications of this edge cloud. We just actually did a conference about a month ago to kind of illustrate to the community what different things you could do with this infrastructure. So I'm going to go through those and show you them, but I really believe it's just the tip of the iceberg. And then at least my thoughts on what this might mean for Africa and kind of what I've been thinking about how CMU Africa could be a hub for digital innovation for children's healthcare on the continent. And like I said, questions welcome anytime. I said earlier, I pulled some slides. So I was invited, this is 2014, it was weird to think, 7 years ago. So that's a photo of me at the CMU Rwanda campus at the old telecom building. And I did this talk on the 5th of June at the 4th floor of the telecom house. And we got to spend a week in Kigali with Bruce and Margie. And then we went off, saw the gorillas, and then did a safari in Tanzania, et cetera. So it was a great trip for all of us. So I was thinking, boy, this has been 7 years since this. Anyway, our Moonshot mission, let me talk about that. It begins really as Tim introduced. I actually served as the first president of Oracle's cloud computing business. Ended up writing this book called The End of Software, which basically highlighted 4 startups: VMware, Salesforce, NetSuite, and Open Harbor. And I'm pretty sure you've heard of 3 of them. So I got 3 out of 4. I've always told people they should have bought the book and bought the stock. So, but I ended up leaving Oracle and returning back to Stanford. I had actually taught core curriculum. I used to teach introductory computer architecture. And I was hanging around the department and they said, oh, come back and teach. I was like, and you guys will appreciate this, that's a lot of work. So they said, well, teach a seminar class. I said, well, that's kind of fun. I know a lot of people. So we put together this class now 14 years ago called CS309A, Cloud Computing. I do the first and last lecture. In between, I have guest lecturers who are pretty much a who's who of CEOs of public companies, ranging from Salesforce through WebEx. And actually, right before the pandemic, 2019, we actually had Eric Yuan from Zoom come to class in the real world. and talk about an idea he had that if he was going to start a company again, he would have no headquarters. And it's kind of amusing considering what's happened since the pandemic. Anyway, the reason I tell you about this class is it is the origin story for this mission. I had a student reach out and say, you know, I'm a little old school. I like to meet the professor. I went, okay. So we agreed to have lunch or have breakfast. I'm sitting there. This guy walks in. I'm looking at him thinking, he doesn't look like a regular student. Turns out he has an MD, an MPH, an MBA, and he's chief of pediatric cardiology at Children's Hospital Orange County. So I already introduced you to Dr. Anthony Chang, who was, quote, back in town to get a master's degree in bioinformatics at Stanford, which some of you know is one of the preeminent areas for the university. It takes Anthony 3.5 years to finish the degree because, number one, he doesn't know how to program. Number two, he still has a real job. He's on call as chief of pediatric cardiology. And number three, he decides to adopt a 18-month-old and a 6-month-old as a lifelong bachelor. So I love telling Anthony's story because I always tell people it's never too late to learn. He believes that AI, big data, and cloud computing need to meet medicine. And so he has ultimately ended up starting a group called AI Med, writing a book on the subject of AI medicine and being kind of a leading light. So because of Anthony, I got introduced to a lot of the community, including, and you just met Alberto in Rome, and I learned a lot of stories about their world. So some of you may already be aware of this, but it's amazing. They still use CD-ROMs to pass information around. A little boy in Southern California went undiagnosed with brain cancer for well over a month because it was too difficult to share an MRI scan between 2 hospitals and 1 clinic. I mean, I don't know that any of us still have PCs or laptops with CD-ROMs on it anyway, right? Anthony's providing consulting for a kid in Myanmar. They want to share the Echo with him. It's too difficult to go do that. At the end of the day, she dies on the operating room table. Anthony gets to see the Echo later and says, oh, I could have told them exactly what to do. One of my old friends is the former CEO of Save the Children. And I was explaining what we were working on. She says, well, you know, pneumonia is still the #1 cause of death in Africa, which leads you to realizing, well, that's not an issue of low-cost scanners. There's plenty of low-cost scanner technology. There's just no one to read the scan. In fact, in Rwanda, there is 1 pediatric cardiologist in the country. So it's fairly obvious that all this work in AI holds a lot of promise to deliver, as Tim opened up, global equitable healthcare, but they're impeded by the lack of data, the lack of diverse data sets. This is actually a conference that was run last year at Texas Children's. I just took screenshots of the presentation, and it's kind of a recurring theme when you're talking to people in AI and medicine is we don't have enough data, we don't have enough data, we don't have enough diverse data in order to drive these deep learning algorithms. And as a result, a lot of these algorithms are fairly brittle. And just to put a finer point on it, in the world of children's medicine, it's fairly clear that no one children's hospital has access to enough data to build non-biased AI algorithms. So I tell you all this preamble to say, well, so what's the problem? Well, it's not that there's not data, there's tons of data. In fact, the Echo Lab at Stanford, just one Echo Lab generates 50 gig of image data per day. So it's not that it's not available. It's not there. It's just not accessible. It's all sitting in a bunch of silos out there. For those of you who are old enough to remember the world before the internet, it's a lot like the world we lived in, where it was Unix systems and NetWare systems and DOS systems. Never the twain shall meet. So we set ourselves, I brought a team together of a bunch of kids, as well as old timers that I've worked with for a lot of years. And we basically set ourselves a mission. And that mission is to enable safe, precise, and as you'll see, privacy preserving data sharing for all million healthcare, from all the data from all million healthcare machines in all 500 children's hospitals in the world. And when I say healthcare machines, I'm talking about ultrasound, CTs, blood analyzers, gene sequencers, blood glucose monitors, et cetera, et cetera. And how do we enable that to allow for a new generation of applications that could fundamentally change children's healthcare on a global basis? So that's the mission that we've organized ourselves around. So how are we going to solve this problem? So we've developed a new technology we've referred to as an edge cloud. So why do we call it an edge cloud? Well, if you on the first day of class, my Stanford class, I basically describe what is AWS, GCP, Azure as center clouds. So what is a center cloud compute and storage service? Well, Amazon or Microsoft, et cetera, buy 1 million servers. They manage the performance, availability, and security of those servers. They deliver them in an OpEx business model, and they locate those servers in about 10 data centers in the world. And what you're seeing here actually is where all the AWS data centers are, right, in the world. And if you saw a map of Google or Azure, it's not a whole lot different, right? Just to make a fine point on it, you'll notice there's no data center sitting in Africa, right? So what are we doing, right? Well, we're saying, hey, we want to do the same thing. We want to provision a lot of servers. We're going to manage the performance, availability, and security of those servers, of that compute and storage. The big difference is we're going to put it in 1 million data centers in the world. In fact, because of the way we've developed this technology, pretty much we can put a 8,000 core, 2,000 GPU, 840 terabyte edge cloud with 36 solar panels pretty much in any building where the sun shines. So the fundamental architecture is to move, as the old timers remember, we've talked about this as client server computing once upon a time, right? This is kind of this all over again. But let's move computing to the edge, because there's a whole class of applications which cannot run or not run effectively in the center cloud. Those that require movement of a lot of data, those that require increased degrees of security and privacy, those that require lower network latency, et cetera. So let's move those fundamental ideas of compute and storage, managed compute and storage, to the edge, okay? So that's why we call it an edge cloud. Let me go down a layer and show you what we are doing. So at the core is edge compute and storage services. So for those of you who speak Amazon, that's EC2 and S3 analog. And in effect, actually, next year, the APIs we'll be using for the edge storage will be S3 APIs, amusingly enough. So these computers, just to give you a sense of this, they're roughly 4 core microprocessors running between 2 and 12 gig of memory, between 32 and 128 gigs of storage, right? About the size of your hand or smaller. So that's the edge compute and storage environment. And I'll show you managed. What does that mean in a second? we have developed edge networking services. Here we're being a little unique. We have architected everything around a wireless first strategy. In fact, one of the team members calls this a wireless data center. So we in effect are engineering around wireless, meaning Wi-Fi, as well as around 5G connectivity. As some of you are aware of, all this 5G technology is coming out. I'm not sure if it has real application to downloading movies faster, but we think it has a lot of applications to this world. And in fact, last year, Ericsson rolled this basically $500,000 worth of equipment in, that's actually the Lucile Packard Children's Hospital parking lot. And we did a test on what the bandwidth, what the latency would be like if we actually lit up the building from the outside from 3 locations using a 5G network. And if you're interested, we published a report with Ericsson and Lucile Packard. It's actually quite remarkable. We thought this would be a really good test of whether this could work well, because Packard was built fairly recently. So it's to California earthquake code. So it has a lot of reflective glass, and as you guess, a lot of rebar in it. So we thought, if it can work here, it probably can work pretty much anywhere. And as I said, the results were quite remarkable. So we'll now move to how this is really very much unique. I mean, I think at that point, I just described to you fundamentally a compute and storage cloud service where the backbone is a wireless network. We know that a lot of the data, and I've already said this, existing in any building is actually being produced by machines. So part of the architecture is what we call a digital twin application. So the digital twins runs at the edge and in essence replicates the data in the machine. So replicates the data in a Beckman blood analyzer or a Draeger ventilator or a GE MRI scanner. Those are just examples of what a digital twin would be. We've looked across a lot of different classes of machines, frankly, including construction machines. And we think the architecture holds up as the ability to build these digital twins. The digital twin job, I said, is to replicate the data. So when I say data, what do I mean? Well, I mean the static data, the environmental data, the dynamic data, and what we call the gnomic data. So what's static data? Oh, well, that's the serial number of the machine. Oh, who's the manufacturer? What's environmental data? Oh, well, what's the location? What's the temperature in the room? Dynamic data. What's the last error log that was thrown? What's the laser power level in the gene sequencer? And then finally, gnomic data. So that's the data that the machine is creating. So whether that's a echocardiogram or an MRI scan or a blood analysis. So these are all standardized by machine type. So once, and we've built this for Philips, Siemens, et cetera, for imaging machines. Once you've built this, then it doesn't matter if the Philips machine is running in Kigali or running in California. The data presented to Edge Data Services as identical and standardized. We are not attempting, just to say it, that I'll make up an example. In blood analysis, Beckman blood analyzers and Siemens blood analyzers, the format of the blood analysis is not identical. We are not attempting to rationalize any of that. All we're saying is, look, if the Beckman machine, Beckman digital twin produces data, it will be identical across all Beckman machines on the planet, okay? So the digital twin produces this data and presents it inside what we call Edge Data Services. Edge Data Services serve a unique purpose, which is both to standardize the data, but also to enable very precise data sharing. So the model we have is every machine, so I'll just say Alberto owns the MRI scan on the first floor at Bambino Gesù. He's the machine owner. he gets to decide whether any data is shared from that machine. So any static, any environmental, any dynamic, any nomic data, any. So he says, well, I'm actually willing to share environmental and nomic data. The next level is with which application. So he can say, well, I'm willing to share it with an application that, Bruce is developing at CMU, but I'm not willing to share it with an application Tim is developing for his enterprise, right? So application by application data sharing. So we see this as very fine-grained capability to control access to that data. This is actually part of 26 different security management features. I'm telling you a little bit about what we call owner data control and application data access control. But as you could gather by us going into this space, we knew security and privacy were the top of mind. And so we engineered everything around security and privacy being design point one. I go into a lot more detail here. We obviously have some problems we have to solve that Amazon does not have to solve. For instance, you can actually walk away with one of our servers. So there's a lot of technology we developed to enable security and privacy management at the edge. Now, what's all this good for? Well, we are presenting all of this to edge cloud applications. So we're trying to standardize all this data, make data secure, enable very fine-grained data sharing from any machine. To what purpose? Well, that's where the edge cloud applications come in. So the edge cloud applications can be designed to run locally. We've actually had some fun and built a voice-enabled application so you could talk to the machine, as an example. Or they can operate by talking to private clouds or public clouds, and I will show you some examples of all of that. All of these applications are developed using what we refer to as Bevel Cloud Studio, which includes documentation, get started guides, the REST APIs for the edge data services, et cetera. So I'm going to pause for a second. I'm going to next go to applications, but I like a little bit of interaction. We're not a very big group. So any questions on the edge cloud?
Yeah, Tim, in terms of the number of digital twins that need to be built, what's the magnitude there, and where are you at in terms of coverage?
Yeah, good question. So I think in healthcare, our guess, we've looked at the inventory to give you a sense of this. Stanford Children's has about 10,000 healthcare machines in the building. I'd say roughly 50 to 100 different types, meaning a Draeger ventilator or a Beckman blood analyzer. So it's not, crazy number. We have done a lot of work in imaging for fairly obvious reasons. We're starting to work in ventilators, et cetera, but EKG monitors, et cetera. But a part of the architecture, in fact, if you went into Bevel Cloud Studio, you'd see this as we want to enable other people to build digital twins. So we don't want to be a bottleneck to doing this. So we've established mechanisms to be able to enable lots of different digital twins. Because as you could gather by what I just said, this architecture is applicable to any machine categories. I mean, like I said, we've looked at construction machines. So we want to enable other people to build digital twins.
Yeah, Tim, I guess it's a follow-up question. So who is actually generating these digital twins, and how much effort is that to, take an example like an MRI machine? So what kind of effort does it take to develop the digital twin for one of those
Uh,
machines?
Yeah, good question. So today, our team, the Bevel Cloud team, to answer your question, is building digital twins. But as I said, we want to open it up to let other people do it. How difficult is it? It depends on the machine. I will tell you, with imaging machines, it isn't that difficult because of the technique that we've used to acquire data and the degree of standardization that's occurred in imaging, meaning DICOM imaging, and the fact that this getting to the detail of it, but our edge servers appear as what's referred to as a secondary pack system inside. So most of the modern machines have the ability to configure a secondary pack. So the ability to integrate imaging machines is fairly simple for the gnomic data. The dynamic data, meaning what's the error log from the Philips machine or the GE machine, is not obviously standardized. And I'll just make a comment. The Philips guys, the GE guys certainly don't make this easy, but we've already done it for the Philips machines. So as long as there are open interfaces to be able to acquire the data, building a digital twin, I'd say is, weeks of work, certainly not months. We don't think it's that hard, to answer your question.
Thank you.
Yeah.
Dan, go
Okay.
ahead.
Thank you, Tim, for this presentation. I mean, so far, very good. I have, so I see the digital twin as like the app store where people develop and now plug into your system. But I mean, I see security issues there when software are developed by other people and plug into your system. So while you were thinking of making that possible, what are the security issues that you anticipate? Another question is that, okay, we have the genome data, it comes from patients. So is there anything that take into account or has already addressed the issue with the patient knowing or not knowing where the data is going?
Yeah. Great questions. Maybe it's a good segue to the next section, because I can talk a little about, you're now starting to talk about privacy as a question. What are you going to do about PII, et cetera? So I'll show you a little bit about that. To answer your question about security, I'll go back. Let me just go back here. You'll see over here, Edge Cloud applications. There's a whole series of things we're implementing because in our world, we're kind of a mix between, when we use AWS as an analog, AWS actually doesn't care what application is running on AWS, right? I mean, anything is fine. Apple, on the other hand, is more constrained. And in this way, we are much more like Apple. We're not saying that, oh, any application can go plop itself on an edge server. So you're seeing there 9 different features that all have to do with us controlling the applications that are being developed and how they get provisioned onto the edge server. So we're much more controlled about how that is than you would see we'll call it in the AWS world. So that, from a security of the application, we could go into, and there's a lot of work in networking, how we're doing this on the networking side, because for fairly obvious reasons, once you hear what I just said, yeah, we're talking to that ultrasound in Kigali. So, how do you make sure that, you're the one talking to that? How is the access to that controlled, et cetera? So we've done a lot of engineering around the network and the network connectivity. And as you can see, also with respect to the compute storage. And, if you want to, there's actually a whole hour-long presentation that maps up to this chart that goes much deeper into how all this gets done. But this is top of mind. As I said, kind of the origin of this entire project made security be the most important thing. So, Tim, I saw you raised your hand.
Thank you.
Yeah, can you say a little bit more about this issue? Like if we're going to do, say, machine learning or these kind of things, you know, just getting all this data to one place to do this machine learning is going to be very difficult. There's 50 gigs, you said 50 gigs a day, and you know, some hospitals don't have 50 gigs a month of data that they have, so that they're able to transmit. So how might you be able to handle that?
Tim, what a perfect setup. Thank you. Perfect setup. So I wanted to take you through what our fundamental infrastructure, right? The digital twins, the edge data services, compute storage, networking, et cetera, and show you that, you know, it's all about developing applications. And so what could those applications be? So what I'm going to do here is I'm going to share with you this link, which I'm sure we could publish also, is actually links to this conference we did on September 20th called Invent 21. And this conference was 90 minutes. We had 6 presentations and I will briefly go through those. So each one of those is about 15 minutes. So if you're at all interested, that link will let you go see all of these about what are the different things that you could do with the Edge Cloud. So we had a very good list of people that came from a lot of different children's hospitals around the world, as well as people who are interested in the research side of this as well. We, as I said, featured 6 different applications. I will walk through this relatively briefly, but it'll give you an idea of what Teleray is doing, UNHCR, Glemdor, Dyad Medical, the work we're doing with the FedML team at USC, and then give you an example of a research application that is in process at Stanford. And it'll, I think, in that answer a lot of different ways you could think about the question you just asked, Tim. So Teleray is actually, amusingly enough, was founded by Tim Kelly, who's another Tim. Tim, well, there's 3 Tims here. This is great. Who's another Tim? So Tim actually was the originator of a lot of the software that burned CD-ROMs for the medical world. So he has taken all of that knowledge and moved to build Teleray, which is to allow image sharing and image exchange, quote, in the cloud. So how does this work? Well, a Teleray application, Edge application, and I'll just pick on the Philips ultrasound there, is running at the edge. If, you know, Alberto or Anthony says, yes, I'm willing to give access to the data to the Teleray Edge application, then the Teleray Edge application will take that image and transmit it to their application, which is actually running on the Azure cloud. So that's an example where part of their application is running at the edge with Bevel Cloud, and part of the application is running at the center cloud in Azure. And then, you know, this is, if you want to think of it, Teleray's kind of like a lightweight PAC system in the cloud, so you can mark up a bunch of other things. So actually, if you go watch the video, Tim takes you on a demo of the Teleray application. Obviously, in this story, one of the huge advantages we provide Tim is by virtue of building a scalable architecture that has gone through all the security and privacy reviews. It enables him to gain access to these machines without having to deal with, which is the most complex thing, going and figuring out how you do PACS integrations across multiple different hospitals and multiple different suppliers. So Teleray is an example of I'll call a collaboration application. Umnitsa is kind of coming from a different point of view. So Umnitsa actually is a company which has built software to do enterprise technology management. Enterprise technology meaning laptops, cell phones, routers, cloud infrastructure. Management meaning manage the procurement, manage security, et cetera, for companies like Pinterest and Apple and Carvana. So the machines they are managing are the classic machines we all think about, servers, laptops, et cetera. I've known the founders for a long time. We said, well, once we connect these healthcare machines, we can apply all the same technologies to being able to manage the healthcare machines. So what in that case, if you allow access to the Umnitsa application, you can now do things like, well, okay, where is the machine? How much was the ultrasound utilized? You can enter into a collaborative service with Philips service team, because not only do we have access to the error log files, but we also have access to the actual image. So this is really an application to rethink how it is you manage in real time fairly expensive resources, including healthcare machines. This has particular relevance. I'll talk a little bit later about this. I think in Africa, where there are a lot of what people will call equipment graveyards, because the ability to provide service and support into the continent is not that good. And so now all of a sudden, because you're connected, right, and have access to the data in the machine, this could be completely different. So that's Umnitsa. You will see a little demo if you watch the video. Now let's go to a question you asked about privacy, Tim. So this is a company called Glendor. So some of you may know this. In an image data, you will have not only metadata in the DICOM format that will have personal information in it, but you can also, in a lot of cases, have it burned into the image. So you'll actually see the name Bruce Krogh in the image. So what Glendor has done is built software to basically automatically de-identify that data. So Glendor is running at the edge. If you enable Glendor to have access to that Philips machine data, then any application can use the Glendor technology to be able to de-identify, and like I said, fully de-identify not only the metadata, but the burned in image data. And then to your question, Tim, you could then take it and transmit it to a center cloud, to a private cloud in Orange County or whatever. But you would be safe in knowing that that data, once it arrived at Azure or GCP, was completely de-identified. Because a lot of people are not sure, they're not convinced that if I send the data into a center cloud, it will be identified when it arrives. How do I know it gets de-identified? Well, in this environment, it never leaves the third floor of Bambino Gesù without being de-identified. So Glendor technology is there to do that, okay? Dyad Medical is an interesting story here as well. So Ronnie is the CEO of Dyad Medical, who's been working on automatic cardiac image analysis in adult medicine. He was very interested in what we're working on because actually his son, quite a few years ago, was diagnosed with congenital heart problems. And so he wants to move the algorithms and what he's been thinking about into the world of children's medicine. So the Dyad Medical, again, would aggregate or aggregates data at Dyad Medical, which in this case, interestingly enough, is also running at Azure. Umnitsa's Center Cloud is running at AWS, just to give you a sense of diversity here. But the Dyad Medical application, so again, Philips application gives it access. Okay, now it can be shared, et cetera. But also what's interesting here is his actual image analysis and interpretation can begin to run remotely at the edge, which is the next step that they're looking at. And again, to your question, Tim, and one of the reasons I reached out to you, what is really super interesting is the world of federated learning. So some of you may be aware of this technology. So federated learning was developed largely on the consumer side. Apple Siri works this way, Google Keyboard. So in those environments where they're trying to do learning, and I like to use Siri as the example, you go, well, if you think the old batch model, you go, well, I'm going to acquire every time you talk to your phone, I'm going to take that data and send it to the Apple Cloud. And then I'm going to crunch on it for 3 weeks, build my ROC curves, et cetera, change my weighting functions. And then I'll go back and deploy out to your phone the new Siri version. Well, that's all well and good, but remember there's 2 challenges of that. Number one, there are privacy concerns because now you have my voice print at Apple Cloud. And number 2, you have challenges with respect to network, because now who's paying for the network transmission of all of that data? You know, you're using up my data plan? I don't think so, right? So federated learning, and I said Google Keyboard, Siri, et cetera, have developed a lot of this technology and pushed the state of the art here. So what we are doing is we see, and other people, in fact, Anthony's also the inspiration for this, see the direct application of these ideas, federated learning. There's another variant referred to as swarm learning, which are ideally suited to the edge. So in this model, what you would see is that the learning would be occurring locally, meaning on the 3rd floor at King Faisal. The data is actually never leaving the building. The only thing leaving is model parameters. Those model parameters could be thought of as either being aggregated at another edge server, that's the diagram I'm showing here, or you could imagine them being aggregated at some center cloud service. But 2 things would be true. Number one, you would never, none of the data would actually ever leave the building, leave the 3rd floor. And number 2, the amount of network bandwidth requirements is significantly lower than trying to ship all those 50 gig, back to your question, Tim, to any center cloud. I think, and I will say this again later, this has tremendous application in Africa to how we want to think about developing AI for that population. Just another point to make, I do think this also represents kind of a very different way to see how learning could occur. And when I'm talking about, obviously I'm talking about deep learning. I think the old model is a very batch-oriented way, which then leaves everybody with a significant question, which is, well, at what point do I retrain the algorithm? And I think this model really allows us to think about what continuous learning might look like, which frankly is, you know, how humans work. So I don't know why we should emulate this batch model. So I think there's a tremendous amount of research and innovation that could occur in federated learning and swarm learning. There are early pieces of work occurring around the world in this. We are going to bring FedML, which is an open source tool that has been developed by the guys at USC, is being brought onto, you'll see this, into the edge cloud. So it's in essence a toolkit to allow applications to be able to use federated learning techniques to be able to develop whatever set of applications that they're interested in. just to make a comment, we're not bound to FedML. There's a number of other things going on out there. If you're a student of this, there's a project at OpenMind. There's a project called OpenFL, but we've been blessed with, because USC and Salman's team has been really interested in the work that we're doing to move FedML to be the first step in this. Which then I can tell you about the work that is occurring at Stanford. This is actually Dr. Charitha Reddy, who's developing this technique to do automatic assessment of left ventricular infraction, which I'm just reading. I'm not exactly sure. I'm sure Anthony or Alberto can explain what this really means. But this is actually an example of bringing algorithms that have been developed over in the adult side into children's medicine, and then taking the next step, which is to implement this using federated learning techniques. So that's just a simple representation of the different applications that we see as possible and some of the enabling technologies. These are 6 applications that are all running on the edge cloud. And our objective in 2021 is to deploy this into what we refer to as 8 zones. So one of those zones, and Alberto is here, is going to be at Bambino Gesù in Italy. And I can't share exactly where all the other ones are, but you can see kind of a representation of where the other edge zones are. So I'll stop there and ask, are there questions about what I just said? Oh, good. Asana.
Thanks, Tim. This is exciting. My questions, how much it would cost to deploy one running version of it? And is it something that we can deploy in a lab setting so that we can build more application, run some experiment on it, or it's just to be done in hospitals?
Yeah, let me take your question in different steps. So just to tell you, this first set of 8 zones, we're deploying at our cost, to answer your questions. So that we're doing that. If you want to think about the business model for the edge compute and storage, it's pretty equivalent to a AWS reserved small instance, just to give you a sense of how expensive it is. So it's not very expensive for the edge compute and storage services. So to answer that question, to answer the question about can we deploy an edge zone, what we refer to as a zone, in other places? So the answer is yeah, we're actually deploying inside what we call Bevel Cloud Labs, which is in Daly City, California. So yes, it can be deployed in other places. We just one of the powers of what we're doing. So what we're saying to everybody who's developing is, first of all, we would, if you were interested, we would open up Bevel Cloud Studio. You could actually run Bevel Cloud Studio locally and use an emulator to emulate the environment. We are fundamentally, just to let you know, and at the lowest level, an Android environment. So it's fairly simple for people to be able to do that, to run in an emulation mode. We also will be providing test servers. As an example, just to link it, we're really interested in how much memory consumption, federated learning, well, how much do we actually need to provide? So we're deploying some fairly fat servers, we call it. If you think about the analog, it happened in AWS as well. They started out with a couple of instance types. They now have hundreds of instance types. So we're going to look the same way. But the cost to deploy is very minimal. Somebody can go on mute. Oh, there. Did that answer your question, Asana?
Yes, definitely. And if we wanted to have a small version of it? I mean, what would be the process? Should I get in touch with you?
Yeah, why don't you talk with me?
Okay.
Yeah, offline. Yeah. Where are you located, Asana?
I'm in the same building as the other team.
Oh, all right. All right. This is going to come up shortly. So yes to everything you just said. Anyway, other questions about applications? Okay, so I'm gonna bring it home. So so what does this mean for Africa? Why did I talk to Bruce and Tim about Africa and about moving what we're thinking about into Africa? This is statistics I'm sure you guys know, but probably I do it for everybody else. You know, Africa is a very young population and getting younger all the time. There are going to be a lot of kids in Africa. It's already home to 1 billion kids. 2 in 5 kids or already will be home to 1 billion kids in 2050, not very long from now. And, you know, I already told you this, there's a single pediatric cardiologist in Rwanda today. So, you know, our techniques of how we want to provide digital healthcare in Africa, I'm going to say should be completely different than what we've thought about in our first world setting. And I already mentioned this to you guys, you know, the lack of healthcare machine maintenance, because you might guess we've spent time talking to the Gates Foundation, is a serious issue in a lot of the developing world, because there's no way to put a Philips engineer, you know, into all these different locations. So lack of healthcare machine maintenance, some people actually think could be the most significant benefit to healthcare in general, is to solve the equipment maintenance problem. Just to make a point of this, is one of the reasons why the MNITS application is very interesting in terms of completely shifting how to think about machine maintenance from the old kind of, I got to send a service guy on site, et cetera, to the new connected state. So if there was interest, we're glad to talk to people, and NITS is glad to talk to people about how this could happen on the continent. But I think the big holy grail here is, you know, how do we push AI for kids, and really AI for kids in Africa, right? So I think we're left with three fundamental, there's probably more, but let's call it 3 fundamental technological questions, right? How do you acquire large Africa data sets? I mean, you know, you can't train, you know, pneumonia diagnostics on kids in Palo Alto or whatever. So how do you acquire large Africa data sets to train on? How do you train while preserving privacy and, probably even more importantly, network bandwidth? You remember the chart I showed you. The nearest AWS data center, I think, is in the UK. So I mean, you know, transmitting a lot of data up to the UK is a non-starter. So how do you train while preserving privacy and network bandwidth? And finally, how do you deploy the inference engine I now have come up with, my pneumonia diagnostic, to the point of care? We think we have the essential infrastructure to solve this problem. How do you acquire large amounts of diverse data? Well, you connect to a lot of machines. And I already made the point that whether I'm connecting the machine in Kigali or a machine in Nairobi, the data from that Philips machine is identical no matter where it is in the world, right? Which enables people, you know, wherever they are, to develop algorithms based on this data. Number 2, I already mentioned this. I think the advancements in federated learning, right, will give us the ability to do privacy preserving and continuous learning in the world of AI with data in the healthcare world as opposed to the consumer world. And then just to make a point of it, because of the way we've deployed, we can deploy it back to the edge. So this is the first time I'm now showing you a photo. So this is actually an ultrasound at Lucille Packard. That gives you a sense of the size of the edge server itself. So the ability to deploy back to the edge, whether that's in, Kigali or Nairobi or Pittsburgh, whatever, is fairly simple because the edge server is local to the machine. So I have a line of thought I'm going to propose here. I would love that CMU Africa would become the hub for development of these kind of applications for Africa. And I'm thinking of that not only with your current students. And so Tim and I talked a little bit about maybe becoming part of this of the practicum in the spring of 22, but also you guys have a lot of former students, let's say now 7 years worth of former students who could also be interested in doing this, because I think that it's really hard for developers in Palo Alto to think about the challenges of healthcare in Africa. So making CMU Africa a hub for development of these next generation applications, I think would be super cool. The next part is applied locally. So actually, again, thanks to Anthony, we've been connected to the folks at Gertrude's Children's Hospital. There's only a handful of children's hospitals in Africa. Gertrude's is one. There's a couple down in South Africa, etc. And so we are already opening up the dialogue with Gertrude's to put a edge zone at Gertrude's in Nairobi. And I'm already opened up actually with introductions by some of the CMU team over at King Faisal in Kigali to put an edge zone at King Faisal. So I think this can now start to bring the clinical community at the Children's Hospital in Nairobi, at the local hospital in King Faisal, kind of together with the smart software people that you guys have. And then the third leg of this, which I had already reached out to Tim about, is, obviously CMU is a leader, has been a leader in the world of artificial intelligence. And I think the ability to now leverage AI expertise that is at CMU in Pittsburgh with the teams on the ground in Africa is so clearly there. And to begin cooperating, if you will, around the rest of the world, at least to me, I think it's just like a really cool thing to use that as the hub for what we're trying to do. So I got a couple more slides and then we'll open up the conversation. Already said it, in Africa, there's a lot of kids. There's going to be a lot more kids in Africa. My question is, are we going to try to do this the old fashioned way and build medical schools and hospitals and whatnot? Or are we going to skip ahead and build a digital future for children's healthcare in Africa? I think the timing is right. I think the people are here to be able to go do this. And so I'm, asking everybody on the line, will you join us on this mission of trying to do this? Because I think it could make a big difference in the world. So with that, I'm going to drop out of slide mode and answer any questions people have.
Let's first
went
thank
a
the
little
speaker.
long. Tim, I
Let's
went
thank
long.
the speaker. That's okay. Let's thank the speaker. Those of you who need to go, please go ahead. I hear, Tim, you're offering to stay a little longer and respond to questions and discussion. So anybody who wishes to stay for that, yes, please go ahead. Maybe we'll start with, I believe, a student, Peter. Maybe you can ask the first question and then we'll go to Kumar, even though that's not the order they raise their hands. So.
Hi everyone. Hi team. I'm so glad I was hi to both of the teams and everyone who's joined in on the call today. My name is Peter Kanda. I'm the Chief Information Officer for Gertrude Children's Hospital.
Thank you for
And,
joining
okay.
me.
Quite, hi, and I'm quite happy with the presentations that I've had so far. In Gertrude, we always believe that we should be leading in terms of trying to adopt technology and to be cutting edge. And so we have a very open culture towards technology and towards partnering in such solutions and also incubating some of these solutions. So from myself as the head of the department, I'm very much willing to be able to host one of the edge servers definitely on our side. We can work on getting in co-location space if you guys want the same, and access to internet and high bandwidth for the same. We try to have quite a stable. We have a quite stable link on our side and redundancy on power and stuff like that. So we can be able to provide at least some stable environment. We can look at what requirements and what entails regarding such. We're very much open to that. We also open to looking at how we can be able to give data access to data and anonymize it, and for it to better research and how it can be able to impact the kind of care that is given to children across Africa. We have 300 GB worth of data. We have plenty more that we are generating from our imaging department on a daily basis. We've integrated quite a few of these platforms also, including our lab equipment and stuff like that. And we have plenty of data being generated on a daily basis. And some of this data we can be able to give access and see how we can be able to anonymize it, especially if it's being done for research and research partnerships and things that are really non-profit and that can be able to help others be able to give better care. So we are happy to do that, and also to host for other non-governmental and government hospitals that will require to maybe access the edge server and stuff like that. So it's quite an open door for us. I'm happy to hear such, and I hope that we can be able to get more guys into such kind of a platform. Thank you.
Peter, if I could hug you, I would.
You yeah, we can always send technology hugs.
Yeah.
We still must maintain a 1 meter distance, though.
Uh-huh.
Yeah, exactly.
We need a digital pair for that. So yeah.
Exactly. Now, let me just say, fantastic talk. Thank you very much. I think some of the things you said towards the end, I find them very fascinating. You know, not that we shouldn't build hospitals or we shouldn't build medical universities. Of course, they're all needed, but this opens up clearly another option too, where that may take time and that may not be, possible. So this is like leapfrogging the technology, and that's very exciting. So the one thing maybe I will just add, it's not a question, it's more of a comment. I think CMU Africa will very much welcome the opportunity to work on these, both faculty and I think students will find it very exciting. But actually there is even a little bigger story. We are at the beginning, maybe Tim Brown may have told you this already, we're at the beginning of actually putting together a network of African universities. We're trying to pull together like-minded African universities that are interested in technology and how it can help in domains of importance to Africa. And clearly health is a very important domain. So we're just starting, but I think in 2-3 years, we may be part of a network of about 10 universities all over spanning Africa. And I think what we do well here can actually be effectively diffused to other parts of Africa. So to me, that's also a very exciting opportunity here.
Yeah, that sounds, I wasn't aware of this, so that's really cool. I, I said it, but I think, the ability for software to transform healthcare it's in front of us. And if we have smart kids in Africa working on this, I mean, it could be completely reinvented.
Thank you.
Tim, are you moderating us?
No, I think I don't see any more questions right now, but this is, I think there's a lot of keen interest. We've been thinking about some different health applications. This could be sort of an interesting angle. We're actually planning a meeting upcoming with the head of research at the College of Medicine and Health at the University of Rwanda. They run the university hospital and things there. And they're actually quite a savvy team. I mean, they've got papers in Nature. They get, New England Journal of Medicine kind of papers. So they're pretty interesting. And so, if you don't mind, we'll pretend like like this is one of our assets, and see what they say. And maybe they'll get some interest to go further. Now, you've mentioned in the past that you've maybe talked to King Faisal Hospital as well, one of the hospitals here. I believe I heard you say in one of your earlier talks.
Yeah. Actually, the chief medical officer and I are trying to schedule time together. So yeah, I was thinking it would be nice to have something super local, even though there is no children's hospital in Rwanda, to be part of this. So that's why I reached out to him.
Yeah, that would be good. And then if we go through the university, there's something called CHK, which is the university hospital as well, which could be an interesting angle. So we'll bring this up with them as well and see if that's see if that makes sense, and try to spin something up. Yeah, I mean, I see some comments in the chat here, like, hey, we can't really get access to these kind of machines. Maybe we can, right, under the right conditions. So maybe we can get some interesting data. So great. Any last comments or thoughts? You're channeling, you're channeling across the ocean and across continents here. It's your opportunity. Any of the students have any comments they'd like to throw out, or questions? I see there's some alums as well. Okay, Ahmed.
Yes, hi, good evening, everybody. And thank you very much, Tim and everybody else for arranging this. I joined a little bit late, but I did hear most of what you had to say. And I'll also be one of the people reaching out to you. Just a little bit of self-advertising. I'm a new faculty here in Kigali. I arrived here from Saudi Arabia. So I have maybe some back channels to King Faisal I could perhaps also help out with. Nice. And Tim, Martin, and a bunch of other people at in CMU Africa and I were talking very recently. King Faisal did come up in some of our conversations. And that's one angle. The other angle is I was also recently involved with a startup based out of California, which does remote sensing in hospitals for various kinds of patients like burn victims and so on. And we're also using a cloud service for that. That's Amazon, but I'm sure there's commercial opportunities somewhere in there also. So it's too short a time to get into everything, but you'll be hearing from me soon. Okay.
Please.
Thanks.
Just as an overall comment before I answer Martin's conversation, anybody that's interested, just I think somebody might have posted, or Tim could post my email address. or connect to me in LinkedIn. I'd be glad to add you. We actually do kind of a monthly newsletter about the whole project, and I'll add you to that list. And I'm glad to talk to any of you one-on-one. Peter, you and I should find time to chat about Gertrude. So, but yeah, so just as a
Sure thing,
comment.
man.
But
Sure.
yeah. Martin, I see your hand is raised.
Yeah, good to see you again, Timothy. Thanks for presentation. Just a couple of thoughts. There aren't a lot of pediatric hospitals for sure, but every hospital has a pediatrics ward. So, we could go down to that level. And we have been having some conversations, for instance, with Rwanda Biomedical Center has a lot of data. That doesn't mean we can get it, but we're making progress. So for certain things, we may be able to connect to some data sets, kind of like what Peter was talking about. And then just for you and everyone else on the call, Tim and I kind of have been trying to coordinate some of our healthcare related efforts here. And in a way, everything we've done looks a lot like a shotgun. But on the other hand, if you organize it from the IT side, it's, we've kind of done data science in some areas, or we've done AI in some areas. And so it's not as much of a shotgun as it looks like. But if you've got different people reaching out to you and you're starting some different conversations, it would be great if you keep kind of Tim and I in the loop, and we're trying to make a coordinated effort here in getting everybody rowing in the same direction.
Just as a comment to you and to everybody, I mean, if you guys want to do a monthly 30-minute sync up, I'd be happy to do that. So
That'd be great.
Yeah.
Okay, great. Thanks everybody for staying the extra time, and I think this is really a great opportunity for thinking about how we can maybe use our skills here, because we want to do things in the health arena, talking cloud, talking networking, talking machine learning. Those are 3 skills we have, pipetting and those kind of things are not one of our strengths. So I think it is a path for us to maybe contribute. And I think there's also some nice synergies here that we are closer to the ground in terms of we can maybe think of some really cool applications from the US, but maybe they don't make any sense here, or maybe they make sense with some interpretation. And so, happy to play that role as well. So very good. All right, so one more time, let's thank Tim, and then we'll sign off. Okay.
Thank you for putting this all together, Tim.
Yeah, no problem.
Yeah.